Hello everyone. In this video, we are going to solve the problem number 1.72 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. So in this particular case, we have to find out the acceleration W of body 2 in this particular arrangement, where the mass of body 2 is eta times mass of body 1. So let us say the mass of body 1 is m, so the mass of body 2 will be eta times m, okay, and this particular mass, that is body 1, is placed on this inclined plane which is making an angle of alpha with the horizontal, and the masses of the pulleys and the threads as well as the frictions are assumed to be negligible. So in order to find out the acceleration of body 2, let us first draw the free body diagram of this body. So this is body 2, and we will have the gravitational force, that is eta times mg, in the downward direction, and we will have the tension force of T in the upward direction. So let us assume that at every point on this particular thread we will have the tension force of T. And let us say this body is moving in this direction with the acceleration of W. So if we write the equation of forces, we can write eta times mg minus T is equal to mass into acceleration. So this is our first equation. And now if we draw the free body diagram of this pulley, then let us say this is the pulley, and the tension force in this particular thread is T, and it will always act in this particular pulley so that it will try to pull, and the tension force cannot push. So we will have the tension force of T in this direction and the tension force of T in this direction. And now let us assume that at every point on this particular thread we are having the tension force of T1. So in this case we will have the tension force of T1 in the upward direction. As the mass of the pulley is negligible, so we can just balance the forces in this direction, and we can write T1 is equal to 2T. So let us say this is our second equation. Now let us draw the free body diagram of mass 1. So this is body 1, and we will have the gravitational force of mg in the downward direction, and we will have the normal in this particular direction and tension force of T1, as every point on this particular thread we are having the tension force of T1. Now this particular body is placed on the inclined surface which is making an angle of alpha with the horizontal, so we can take the component of mg in the tangential and the normal direction. If this particular angle is alpha, then this particular angle will be 90 minus alpha, and this angle will be alpha. Now let us take the component of mg in this direction. It will be mg cos of alpha, and in this direction it will be mg into sin alpha. Now let us first balance the forces in the normal direction. So we can write n is equal to mg into cos alpha, as we are not having any acceleration in the normal direction. Now let us assume that we are having the acceleration of W1 in this particular direction. So we can write the equation of forces, that is T1 minus mg times sin alpha is equal to mass into acceleration W1. So let us say this is our third equation. If we carefully look at here, we are having the variable of T, W, T1 and W1. So we are having 4 variables, but we are only having the 3 equations. So that means we cannot obtain 4 variables with the help of these 3 equations. In that case, we will need the fourth equation. For that, what we can do, we will say that work done by all the internal forces is equal to 0. And in this particular case, we are having only internal forces, that is tension force. So if we talk about body 1, then in the body 1, we are having the tension force of T1 and it is moving in this particular direction, let us say by the distance of x. Okay, and if we talk about body 2, then in the body 2 we are having the tension force of T in this particular direction, and let us say it is moving in this direction with the displacement of y. Now if we differentiate this x with respect to time, then we can say velocity is equal to, let us say v1 is equal to dx upon dt, and here the velocity of body 2 we can write it as v2 is equal to dy upon dt. Let us differentiate it again. We can write the acceleration of w1 is equal to d square x upon dt square, and here we can write w2 is equal to, or we can say w because it is having the acceleration of w, that we can write it as d square y upon dt square. Now as we have said that work done by all the internal forces should be is equal to 0. So here the work done will be T1 times x, as this particular body is moving by the distance of x, and plus as both the forces and the displacement are in the opposite direction. So we can say we are having the work done of T times y is equal to 0. So from here we can write T1 into x is equal to T times y. Now let us differentiate both the sides. So we can write T1 times dx upon dt, that is equal to T times dy upon dt. Now let us differentiate it again. So we will get T1 times d square x upon dt square is equal to T times d square y upon dt square. Now we know that d square x upon dt square is w1, so we can write T1 times w1 is equal to, here d square y upon dt square is w, so we can write T times w. Now we have already found out the relation between T1 and T, so let us substitute it here. So we will get T1 is equal to 2T times W1 is equal to T times W. Okay. So from here we can get W1 is equal to W by 2. So that is the acceleration of body 1 is half of acceleration of body 2. Okay. Now let us substitute the value of W1 in the third expression. So we can get third expression as, that is T1 minus mg times sine alpha is equal to mass into W1. So we will get mass into W1 is W by 2, and we know that T1 is equal to 2T, so we will get 2T minus mg times sine alpha is equal to mw by 2. Now let us consider the first equation, that is eta times mg minus t is equal to, this is eta times mw because mass of this particular body is eta times m. So we can write it here, eta times mg minus t is equal to eta times m into w. Now we have to eliminate tension T from both these expressions. So let us multiply this particular expression with 2. So from here we will get 2 times eta mg minus 2t is equal to 2 times eta times m into w. And let us add equation 4 and equation 5. So we will get 2 times eta mg minus mg sine alpha is equal to 2 times eta mw plus mw by 2. Okay. So let us take the common mg from here. So we will get 2 times eta minus sine alpha is equal to, if we take the mw common from here, so we will get 4 times eta plus 1 by 2. Okay, here mm will get cancelled, and from here we will get w is equal to 2g times 2 eta minus sine alpha whole divided by 4 eta plus 1. So this is the acceleration of body 2 we got. I hope the entire procedure is clear. Thank you.